Hello, let's solve the 2008 AMC 12A question 20 together. So in this case, we have triangle ABC, which is an isosceles right triangle. Its sides A, B, and AC are both equal to 3. And the hypotenuse BC is just 3 times square root of 2. Let M be the midpoint of the hypotenuse BC. So CM and MB are both half of the hypotenuse. So they're equal to 3 root 2 divided by 2, or just 3 over root 2. Point I and point E are sides on AC and AB, so that AI is larger than AE, and AIME is a cyclic quadrilateral. There is a property for a cyclic quadrilaterals that the opposite angles are identical, so angle IME and angle IAB are both equal to 90 degrees. So EMI has an area of 2. So since we found that EMI is a right angle triangle, the area is just equal to 1/2 times the base or times the height. So it's equal to 2. So IM times EM is equal to 4. And well, we need to find the length CI in this question. So by observation, we will find that if we can prove that triangle IME is isosceles, then we can just find the length easily. So now let's just try to prove it's isosceles. So we can just extend M to F and G, and both of them are perpendicular. Since M is the midpoint, we can deduce that FM is equal to MG. If you would like to prove it, you can just further prove it using similar triangles, but it's quite deducible. So now let's try, and we also have the two angles being 90 degrees, so angle MGE is equal to angle MFI, which is equal to 90 degrees. Now let's try to find if there's any other conditions. So first of all, we can just let this angle be equal to x, and this angle will be equal to 90 minus x. Then we can let this angle be y. So this angle over here will just be 100 degrees minus 90 minus y. So it will be 90 minus y degrees. Nextly, we can find this angle. This angle over here will just be 180 degrees minus 90 minus x. So it would be just plus x minus y. So 90 plus x minus y. So we can just find this angle over here. This angle will just be 180 degrees minus 90 degrees minus the 90 plus x minus y. So it will just be equal to y minus x. Okay, that's great. So we can find this angle, which is just equal to 90 minus y plus y minus x, which is equal to 90 minus x. That's great. So now we have proved that these two angles are equal. Angle MEG is equal to angle MIF. That's great. So we know that these angles are congruent triangles now. So we can say that ME is equal to MI, which is great. So we know that each of them has a length of 2. And since we know that ABC is an isosceles right angle triangle, this is just equal to 45 degrees. So now we can use the law of cosines to solve the problem. So the law of cosines states that if here is a triangle ABC beta, A squared is just not A squared. B squared is just equal to A squared plus B squared minus, A squared plus C squared minus 2 AC cosine theta. So in this case, theta is 45, which is just the opposite angle of IM. So we can write that IM squared is equal to CI squared plus CM squared minus 2 CI CM cosine 45 degrees. IM squared is just equal to 4. CI squared is what we are trying to find. CM squared, or 3 divided by root 2 squared, is just 9 over 2 minus 2 CI 3 over root 2. Cosine 45 is equal to root 2 over 2. So these cancel out. These cancel out. 4 minus 9 over 2 is just negative 1 over 2 is equal to CI squared minus 3CI. So we can have 0 equals to 2CI squared minus 6CI plus 1. So we can just use the quadratic formula to solve this. CI is equal to 3 plus square root of 7 divided by 2, or 3 minus root 7 divided by 2. And we know that CI must be smaller. CI must be smaller than 2 because it's the shorter side. And this one over here is larger than 2, so it's rejected. So our final answer is 3 minus, the length of CI is just 3 minus root 7 over 2. So our final answer is just 3 plus 7 plus 2 equals 12. So our answer is D. Thank you so much for solving the question with me. I really enjoyed it, and I hope you enjoy it too. Bye!